All right, everyone. Welcome again. These are going to be the solutions for written response question 2 and written response question 3 from your unit exam. What you're looking at on the screen right now is written response number 2, and you're looking at the sailing boats question because in question 2 you can either do the sailing boats question or you could do the question that had a conical reservoir of water. So what you're looking at is number 2 for those people who chose the sailing boats question. And there are two versions of this exam. If you were to look at the front page of your exam in the top right, well, actually the top left corner, I suppose, you will either see 1 dot or 2 dots. So 1 dot is version 1. If you take a look at version 1, it says Nikki is in a boat that's 60 miles north of Paulo, and Nikki is sailing south at 12 miles per hour, whereas Paulo sails west at 15 miles per hour. When you look at number 2 for exam 2, it's essentially the same question except I've switched the rates at which Nikki and Paulo are sailing. So in either case, your setup for this is going to be that Nikki starts north of Paulo. This is where Nikki starts. Paulo starts 60 kilometers south of Nikki. Paulo sails west. So Paulo is going to sail in this direction, and Nikki sails south, which means at any particular point in time later on, Nikki will be here and Paulo will be here. And it doesn't matter whether this is drawn to scale or not, and what I'm attempting to do is to draw one diagram that we could answer question 2 for, whether you have exam version 1 or 2. In either case, you need to call the distance that Paulo travels x. I guess you don't have to call it x, but it's reasonable to call it x because it's a horizontal distance, and the distance that Nikki travels y. And you can construct out of this diagram now a Pythagorean triangle that shows the distance between Nikki and Paulo at some later time. It also shows this distance, and it shows this distance that Paulo sails. And you want to be very careful here. If this total distance to begin with was 60 miles, then the distance in the Pythagorean triangle would be 60 minus y. So this little leg of the triangle is 60 minus y. And traditionally we call this distance between the two ships at a later point in time z. So in either version of the exam, this is the setup. And your equation that you're going to develop will be the Pythagorean relationship that the hypotenuse squared equals the sum of the squares of the other two sides. So this is what you're going to use to differentiate to solve the problem. And when we differentiate this, remember it's a related rates problem. We're differentiating with respect to time. So 2z dz dt is equal to 2x dx dt plus 2 times 60 minus y times the derivative of 60 minus y with respect to time is negative dy dt. So whether you're doing version 1 or version 2, whether your exam is version 1 or version 2, if you chose the sailing boats question for number 2, this is how you're going to get the answer to the question. Now, let's talk about the difference between these two. So if you're looking at exam version 1, dy dt is the rate at which Nikki is sailing, and she is sailing south at 12 miles per hour. So dy dt is 12. dx dt for version 1 is how fast Paulo is sailing, and he's sailing at 15 miles per hour. And in version 1, you're trying to find dz dt. So this is version 1. If you're looking at version 2, Then dy dt is the rate at which Nikki is sailing south, but in version 2, she's sailing south at 15 miles per hour. Dx dt is how fast Paolo is sailing, and if you're doing version 2 of this question, you have version 2 of the exam, you're doing the sailing boats question for written response 2. Paolo is sailing at 12 miles per hour. And of course, you're trying to find dz dt. You also need to know the value of y and the value of x at this later point in time to answer the question. And although I'm not going to show the work here, I expected you to show your work and how you got it on the exam. If in the first version's question, Nikki is sailing south at 12 miles per hour, then 1.5 hours later, you would take 1.5 hours times 12, you would get 18 miles. And if we take 1.5 hours times 15, you get 22.5 miles. What's going to be different is in the version 2 question, these numbers will be opposite because I've changed the speed, so x will be 22.5, y will be 18. So if you take a look at everything in the equation in the box at the bottom of the screen, and by the way, I would highly recommend canceling those 2's by dividing both sides of the equation by 2, you need to know dy dt over here on the right-hand side, and dy dt is known. It depends on which version of the question you're doing, but dy dt is 12 in version 1 and dy dt is 15 in version 2. You need to know y, and we've already calculated y. You need to know dx dt. Well, you were told the rate at which Paolo's ship is sailing. You need to know x, and we've already calculated that. So the only thing you don't know is z. But what you can do, I just want to make a little room for myself here. What you can do to find z is use this relationship here to calculate that z equals the square root of x squared. So in version 1, that would be 22.5 squared plus 60 minus y squared. And in version 1, that would be 60 minus 18 squared. If you do the same type of thing, if you happen to have exam version 2 when you did this question, you would get z equals the square root of x squared, and x is 12 in version 2 squared, plus 60 minus y squared, and y has a value of 22.5. And I am not going to do the calculations in this video. Essentially what you're going to do, if you're looking at version 1, is you're going to put dy dt is 12 into the equation in the box, dx dt is 15 into the equation in the box, y equals 18 and x equals 22.5 into the equation in the box, and then you're going to have to also put in z, whatever number you get, in for z. So to finish this off, dz dt would be equal to x dx dt plus 60 minus y dy dt, well, negative dy dt. That's actually very important. Don't forget that it's negative dy dt. So when you put in dy dt in version 1 of 12, it's going to become negative 12. And then we have to divide by z, which you calculate on the side. If you were doing version 2, then you're just going to have a whole different list of numbers to put in for x, dx dt, y, dy dt, And of course, your Z will be different as well because you have different numbers to calculate Z from. So that's written response question 2 if you chose to do the sailing ships question. Written response question 3 talks about a conical reservoir that is being filled with water at a particular rate. So again, I'm going to choose to put information for version 1 on the left, and I'm going to put information for version 2 of this question on the right. When you're told that water is being pumped into the cone at 12 meters per minute, what you are told is the value of dV dt, and it's positive 12. In the second version of the exam, this question has dV dt equals 14. And it's positive because water is being pumped into it. Everything else is the same. Both of these questions have a depth of the reservoir of 3 meters and a radius of 24. So this is quite an extremely, I would describe it as flattened reservoir. And I'm not going to draw this precisely to scale because I just don't have enough room. But the reservoir is conical. So what you're looking at is a reservoir that looks like that, and the distance across the top of that entire reservoir is actually 48 meters because it says the radius of the reservoir is 24. So let's put in 24 meters for the radius, and this is the radius of the reservoir. It's not the radius of the water that's in the reservoir. And then I'm also going to put in 3 meters for the depth. And clearly this is not drawn to scale, but that distance there, this is 24, this distance is 3 meters from this point to this point. And I'm not going to attempt to draw in a column or a three-dimensional piece of water in there, but what you need to understand is no matter how full or empty the reservoir is, the ratio of the radius of water to the depth of the water is going to be the same as the ratio of 24 to 3. In other words, the radius of the water over the depth of the water, and I'm going to choose to use h for depth, has to be equal to 24 over 3, and we can simplify that a little bit and say that the radius over the height is equal to 8. And this is going to be what you're going to have to use at some point to eliminate a variable that you don't want. If we look now at the question, what the question is, what is the rate of change of the depth of the water? So that's dH dt. You're trying to find dH dt from dV dt. And again, it depends on which version of the exam you have when it comes to the rate of change of volume. But regardless of which version you have, the fact of the matter is the volume of a conical reservoir is 1/3 pi r squared h. And we want to keep v in this equation because we have a dV dt. We want to keep h in this equation because we want to find dH dt. But the fact of the matter is, we don't know dr dt, and we don't, as a result of that, want r in there. But if you take a look at the equation at the top of your screen right now, r over h is 8, and that means if you cross multiply or multiply both sides by h, however you want to look at it, the radius is 8 times the height. And what we can do now is, in the equation where we see radius, we can put 8h instead of the radius. And again, our motivation here is you want to keep all of the variables whose rates of change that you either know or want to know, and everything else gets thrown into the bin. So let's do that substitution first. We have v equals 1/3 times pi times r squared, well, r is 8h, and it needs to go in brackets because we're squaring it, and then times h. By the way, just before we go on, if you wanted to know my opinion, I think this related rates question is a lot simpler and a lot less work than the one that has Nicky and Paolo sailing in ships. We simplify this first before we differentiate. I've got the over 3 part. I've got the pi. When I square 8h, I get 64h squared, and h squared times this other h is h cubed. All I have to do now is differentiate this equation with respect to time, do a little bit of substitution, and then basically be done with it. So dv dt equals, I'm going to wrap that exponent around the h, and I'm going to take 64 pi over 3 times 3, which will give me 64 pi. I drop one exponent from the h to get h squared, and then I multiply by dh dt. All I need to do now is put in the information to find dh dt. So if I go back up here to the top, I knew dv dt was 14 in version 2. Just move this information down for us so that we can see it. We were also told in both of these questions, find the rate at which the water level is changing when the depth is 0.2 meters. And that's really one of the other reasons that this question is a lot simpler than the Nicky and Paolo question. Because for both of these, you're told at that point in time, h equals 0.2. When you go back and look at the Nicky Paolo sailing boat question, we had to calculate an x, we had to calculate a y, we had to use the Pythagorean theorem relationship in order to find out z, and it was a little bit more work. Well, I could probably argue it was a lot more work. So if I'm doing version 1, I guess I can just quickly show you both. Version 1, I will have dv dt, which is 12, equals 64 pi times h, which is 1/5 squared, times dh dt. And you're going to rearrange that for dh dt. If I do version 2, I have dv dt, which is 14, equals 64 pi times h squared. H is 1/5. That's what 0.2 is. dh dt. And in either case, I'm not going to rearrange this for you. In either case, you are going to rearrange the resulting equation for dh dt and be done with it. All right, let's take a look now at written response number 3. So written response number 3, forget about the version of the exam that you have. I'll show you one particular version. I don't know which version this is. It looks like maybe it's version 2. Both of your options for this question involve a box with an open top and a square base. The difference is one of the options has a fixed surface area and you want to maximize the volume. The other option, the second option, has a fixed volume and you want to minimize the surface area. So I'm going to go through the solution to the question where you have a fixed area first. What we're looking at then here is question 3, where we have a fixed area of 5,000 centimeters squared if you have exam version 1, and question 3, which has a fixed surface area of 2,000 centimeters squared if you have version 2. I've also put on the screen a diagram of a box with a square base and an open top. I just realized right now, I just pulled this off of the internet. It's probably better visualized to you if you see these lines. Because you're looking into the center of the box here, so you would actually see those lines. But maybe that's splitting hairs and is not that important. So you have to really organize your thoughts carefully here. Whatever exam you're looking at written response question 3, the first option, where you have a fixed surface area. And if that's the question you did, you need to understand that this is the constraint equation. And I will get to the structure of this equation in a second, but this is the constraint, and this is to be optimized. So why is it we have volume equals s squared h? Well, it's volume equals s squared h because when you look at the volume of a box, or what your math teacher would probably call a rectangular prism, it's length times width times height. So what I'm doing here, I'm going to actually erase this. You should already know the bottom equation is the equation of constraint. The top one is to be optimized. If I call this distance s and this distance s, well, they're equal because it's a square base. Then I can call the height of this h, and length times width times height gives you this formula, which is what we're trying to optimize. Whereas if you calculate the surface area of that box, the area of the front of the box is a rectangle, which has an area of sh. And there are 4 equal sides. Left, right, front, and back are all the same because they all have the same height, and it's a square base. So that's where the 4sh comes in. The area of the base is s squared plus 4sh. So I've set the tables now for solving this problem. We want to maximize volume, so we start off with this formula. But, and this has nothing to do with related rates. In a max-min problem, the thing to be optimized needs to be expressed in terms of only one other variable. Because what you want to do is you want to find dv ds or dv dh. But you can't have multiple independent variables in a max-min problem. So this is where your equation of constraint comes in. If you are doing version 1, this question on version 1 for the exam, your equation of constraint is that 5,000 equals s squared plus 4sh. If you're doing version 2, if you have a version 2 exam and you did this particular question, which was the first option for number 3, your equation of constraint is 2,000 equals s squared plus 4sh. And I think it would be worthwhile for me to actually complete both solutions here. So with version 1, you are going to substitute in h from this equation here. So if I rearrange that equation for h, this is kind of, I mean, you would show this on an exam, but I don't want to fill up the board space with it. It's just kind of my scrap work here. You would have to take 5,000 and subtract s squared and then divide everything by 4s. And that's how you would get h. So that's going to give you, well, 5,000 divided by 4 is 1250. And we have s to the negative 1. And then over here we have, we can work in decimal if you like. 1 over 4 is 0.25. So minus 0.25. S squared over s to the 1 is s. So 0.25s, that's my h. H equals 1250 s to the negative 1 minus 0.25s. So I would put that in there. 1250 s to the negative 1 minus 0.25 s. I want to just confirm that before I go on. It's good. if you were doing version 2, so you're going to have to follow this video carefully. I'm going to intersperse the different steps of version 1 and 2. So I've done the substitution in version 1. Actually, you know what I will do first is I will clean this up. This is still version 1. I'm going to multiply that s squared through and get 1250s minus 0.25s cubed. All right, if you're doing version 2, you have to substitute in whatever h is equal to from this equation of constraint. And I won't go through all the steps with this one. I will just go ahead and tell you that if you rearrange this equation for h, you're going to have to subtract the s squared and divide everything by 4s, and you will get 500 s to the negative 1 minus 0.25s. And we can multiply that through and get v equals 500s minus, I'm missing an s here, 0.25s, minus 0.25s cubed. Look, there's not much left to this question. If you're looking at version 1, you now have to differentiate this equation. This one right here. And you'll get, I think I'm going to, just to make it a little easier for you to follow, I'm going to stop staggering these, and I'm going to put version 2 over here. If I had more time, I would redo the video, but I don't. So, and I'm going to put version 1 over here. I think staggering them was a educational mistake. I think it made it maybe a little bit more confusing. So there's version 1 after your substitution and simplification. There's version 2. I differentiate and I get dv ds equals 1250 minus 0.75 s squared. There's a lot of ways that you can find the critical values of s, but essentially if you set this equal to 0 and rearrange it, you will have s squared equals 1250 over 0.75. So you can take plus or minus the square root. You'll have two critical values of s. You'll have to discuss on an exam which one is no good and throw it out. Once you know the actual value of s, then you can calculate the value of h, because I believe the question said, what are the dimensions? So determine the dimensions. Over here with version 2, if you had version 2 of the exam and chose to do this particular question, you'll have dv ds equals, we're differentiating here, 500 minus 0.75 s squared. So that means dv ds, when you set it equal to 0, will lead you to s squared equals 500 over 0.75. And you can do the same thing that we did with the other question. I have one more question to go over, and that's the square base open top box with a fixed volume. And what you want to do here is minimize the surface area. So the difference is, and I'm going to structure this side by side, that in version 1, you have a fixed volume of 2,000. So 2,000 equals s squared h if you're doing version 1. And if you're doing version 2, it's 5,000 equals s squared h. And these are your equations of constraint. You're trying to minimize the area, so when we write down that equation, area equals s squared plus 4sh. And again, you have a problematic variable. We have to get rid of one of these two variables, s or h, in the area equation, I mean, I would recommend getting rid of h. Why would you want to get rid of s when it occurs in two places? So what you can do in this equation is wherever there is an h, put in the result from this equation when you divide both sides by s squared, which is 2,000 over s squared. The same thing would happen over here. You would have a equals s squared plus 4 times s times, well, rearrange that equation for h. You'll have 5,000 over s squared. Remember, with any max-min, everybody, you want to simplify completely first. So a equals s squared plus 8,000 s to the negative 1. Here, a equals s squared plus 20,000 s to the negative 1. I mean, we're almost home free here. You're almost to the point where you can get an answer to the question. Let's differentiate now. If you're doing version 1, you'll have 2s. This is dA ds. You'll have dA ds equals 2s minus 8,000 s to the negative 3. Pardon me, s to the negative 2. So what can we do here? We can factor out a 2 and an s to the negative 2 and be left with s cubed minus 4,000. So, I mean, you probably should address the critical value here of s being 0, but that's not a possible solution. The critical value here that gives you the solution will be the cube root of 4,000. When you do the same thing over here, you'll have dA ds is equal to 2s minus 20,000 s to the negative 2. So again, factor things out. What can we factor out? A 2 and an s to the negative 2. What do we have left here? S cubed minus 10,000, which will mean s will equal the cube root of 10,000. Regardless of which version of the exam you have, if you chose this question, I don't think you're done yet because it says determine the dimensions. Once you determine the length of the side, then you can go back and square that length and divide it into your volume to get the height of the box. Anyway, I hope that's helpful. Enjoy the rest of your weekend, and we will see you guys all on Monday.